morning. Today we want to continue in our packet. So we're at part 3 today. And part 3 is what is called a test cross. So the only thing you really need to know with this is that you're going to mate your known parent with a pure recessive. And then that will give you the option of knowing, was this homozygous dominant or heterozygous dominant. So if you just mate back the information with pure recessive, you should be okay there, and then have questions to answer. So we're going to continue on with part 4, which is incomplete dominance or codominance. So you have a handout. You have actually a stack of 3 handouts in your possession, and the first one looks like this. Codominance or incomplete dominance, and there are a few others, are known as multiple alleles because we have more than one thing that is going to give you the genetic information to code for a specific trait. One of the forms of multiple alleles is called codominance, where you have neither trait that blends with the other trait. So you might think that white and red is going to give you pink, but it doesn't always do that. In codominance, white with red it could be white with red speckles, or it could be white with red stripes. So this is how we get such variations, often in animal and animal fur colors. This handout, though, is specifically about incomplete dominance, which is when you get an actual blend of colors. So in this case, yes, red and white makes pink. So we want to show how does that happen. So most of you have done this in first year bio, and I think the thing that's different for you here is the key. We use the little slash mark, which is the prime symbol. So you have red, big R, and you have white, R prime. And the mix of these, one red and one white, gives you pink, R prime, or R prime R. They mean the same thing. So some of you in first year bio used big R, big W, RW is pink. You can do your cross that way, just know that this is the more correct way to write it. So in this case, it's asking us to cross a red with a white. Red is big R, white is R prime. When we do the cross, all of our offspring come out to be R prime. Then it asks us to do, so our F1, all of our offspring are R prime. To show an F1 cross now, we're going to take 2 pink babies. So we take any of the babies from the box and we mate them with each other. And we end up in a situation here where we have R prime times R prime. Genotypically, too much info. Genotypically for our F2, we have big R, R prime, R, and R prime, 1 to 2 to 1. So phenotypically, what do they look like? We have 1 red, 2 pinks, and 1 white. Let me backtrack to here. From my F1, I still have to fill out my genotype and phenotype ratios. Big R, R prime, a 0 to 4 to 0 ratio. Red is 0 to 4. Red to pink to white is 0 to 4 to 0. And then I took those 2 pink babies and mated them here. So we have the F1 and F2 offspring. These would be considered F1. These would be considered F2. Below it asks you to do the following crosses. So if you cross a red flower with a pink flower, your red parent is RR, your pink parent is RR prime. We'll just show you so you can check your work. White flower with pink flower, R prime with RR prime. Check your work. And then it goes on to talk about guinea pigs. Here we have some different traits. One is white. Their offspring are cream. One is tan. So we have tan with white gives you the mix or the blend, which is cream. So here you can do big T for tan, T prime for white, T prime for cream. This is a blend of the 2 colors, one of each. Taking a tan with a white, do the cross and see what your offspring become. That will allow you now to go back to your packet and work in section 4. It has the traits for you. It uses the prime symbols for the most part. And Ms. Lum's going to pick up with part 5, multiple alleles.